All right. Hi, my name is Fakhar Nadeem, and my roll number is st20319060. And this is my presentation for the assessment of DAS 7005. So, first of all, we'll go through our app. I've already opened it before to save some time. So, this is basically our app. I have made four pages. This is my main page. It shows that what main pages we have in our application. So we have view data overview, EDA, and our models. Now in the next page over here, we have our data overview. This shows us all our data, which is scaled because we will be using scale data in our modeling. This is our basic info. So it shows all our data count, mean, and standard deviation, minimum, max, and all. It also shows the if there are any missing values in our code data set. In the next page, we have our EDA. EDA shows obviously our shape and size of our data set. These are all our rows. These are all our columns. This is, for example, my AQI. So it shows us the quality index of a specific place. So I have all these pollutants ready over here. I won't go through them right now because we don't have enough time. The, after that, we have univariate analysis. So this is basically it shows the frequency distribution of every single pollutant or any variable that we want to see. And after that, we have bivariate analysis. For binary analysis, I have also incorporated these two columns so we can add or I mean change any other axis of this and see the changes the in the plotting. For example, for over here, we can see that this is a very positively correlated for PM 2.5 and PM10. This is very positively correlated because the line is very straight going and there are a few outliers, so that doesn't matter that much. After that, we have multivariate analysis. In multivariate analysis, we have this whole chart. It's called a heat map, basically. So what happens here is the places which are like red or darker color are if it's orange or red, that means it's positively correlated. So basically, when CO rises, NO2 will also rise for this one. But for example, if this is a negatively correlated, so for example, O3, it will decrease when O3 will decrease when NO2 rises. So this is how negatively correlation works. So this heat map basically explains this whole system. After that, we have time series analysis. So in time series analysis, we have it shows basically the trend over like a yearly trend of every single pollutant. So we can also go through all these pollutants, but since we have short time, we're going through this instead. These are two features that I incorporated. So PM ratio and SO ratio. So PM ratio is basically the the they're basically if you divide both of them, it gives you a number which is more hazardous to ourselves than others. And SO2 over NO2, this basically can and indicate any vehicle or industrial uh, pollution in a place. And this chart basically shows that there are a few peaks over there, but most of it is going uh, steady. And over here, it was a very high peak in the start, but after 2014 mid almost, it has been very straight. And this is our EDA. Now to go to our next next application. Okay, next page. Sorry. In next page, we have our model building. First, I have shown what from the whole data set, how much I have taken for testing and how much I'm training it on. So this is our plot for that. I'm using PM2.5 as my target. So for linear regression model, the result is MAE is 0.02. So basically, this is the there's a very less chance of getting any errors. And RMSE is basically the same as MAE, but it mainly works on bigger errors. So that's why it's a different thing. And R square basically tells us if it's more fitting to the actual data set that we are training it on. And the higher it is, the better it is. So R square is 0.98, which is very good for this. For KNN model, uh, for the KNN model, I have also put this slider over here so we can change the K value of our model. And for this as well, we have 0.03, 0.04, 0.95, which is slightly less than the linear model, but it's still very effective. After that, we have support vector regression. We also have MAE 0.03, RMSE 0.04, R square 0.96. So this is and this random forest model, I actually wanted to incorporate this, but I forgot to remove this block from my code because I didn't do it in the end. But it's still here, so we can use it as a an example of overfitting. So basically, it shows that the model is perfect, and which is in most cases, in almost every case, is not a good thing to do because it shouldn't be that way. So after that, I have also com done a comparison of all these models. So over here we can see that linear, the less it is, the better it is. So in MAE, linear is better than KNN and SVM, and all in RMSE, the less is better. So linear is better than KNN and SVM. And in R square, we have R square, the more it is, the better it is. So linear is better than KNN and SVM. And in all of these, we can see that random forest is exactly the best in all of them. So we're not taking it into account for it because this is not what we need in the end. And after that, we have our code. I have also provided the link to my GitHub commits. So for this, we have basically I've made these places so I can just open them and show you the code. So for importing libraries, I basically imported all the data sets and loaded the files. Yeah, these are the ones that I chose. These are the four data sets that I chose to do my whole project on. And after that, I cleaned every single one of them separately. So urban data set, I checked null values, removed duplicates, handled outliers, corrected data types, and yes, since I have very less time, so I can't go through every single one of them, but this is how I did for every single one of them. I can show you the code real quick. So this is null values. For null values, I just checked the null values, and I if there were null values and there were less, I dropped them, and sometimes I even filled them. So yeah, that's that. And I removed duplicates. It's a simple code for that. And for handling outliers, I used Z-score and correcting data types. I Yeah, I changed the uh, date, month, and year to one column and also reiterated. So yeah, that's what I did for cleaning, and this is the same thing for the whole thing. And in the end, I saved the whole into one data set, merged it all, so I can move on to EDA. In EDA, we have our shape and size. It just previews it, checking for null values after uh, merging if there are anything left, uh, in detecting duplicates as well. Then we have our summary, what we have at the moment. And then afterwards, we have our univariate analysis. So I uh, analyzed every single one of the pollutants. So this is how we have seen in the application as well. And yeah, for bivariate analysis, I have compared them to all sing every single pollutant to every single uh, condition, so temperature and everything. And that's how bivariate analysis goes. And then we have a multivariable analysis. This is just a correlation heat map that we have seen in the application. Time series, there we go. Time series, so we can just see basically that every single pollutant has its own time series code that we have seen in the application. And future engineering, this is the one that we saw earlier, PM ratio. And I've also given the uh, reference for this, that where I got this from, information from, and SO ratio as well. I provide the link to them in the end. So that is future engineering. Now in the model building, we have split data first into X and Y's, and then we distribute the plot and show the distribution of the plot that we've seen earlier in the model page. Then we have linear regression. So yeah, this is basically the same thing. MAE, RMSE, R square, everything, which shows the same answer that we've seen, or the same output. And same goes for KNN, and same goes for SBR. This is where I originally planned to do the pre random tree forest, but I did not do it, but I forgot to uh, remove it from the other the Python file that Streamlit has. Yeah, I also wanted to say that I have used Streamlit for using opening this application, and I connected it to GitHub, and that's how I have been using. Uh, not I am not using it as a locally link. This is an openable link and easily usable. So anybody with a link can open my application and see through my whole data set and my work. And this was my work. This was my assessment. I hope that I covered everything. Thank you.